Okay, so your first step is always look for a GCF. What would be my GCF? Negative, what else? 2 with negative x squared? Negative 2x. We're going to divide everything by negative 2x. And actually, let me stop there before we continue. Let's talk about end behavior. This is a odd negative graph. So because it's odd negative, I know that the right arrow is going to do what? Go. Because it's negative, what is it going to do on this side? Go down. Because it's odd, what is it going to do on the left? Go up. That's really important. Okay, so now that we know our end behavior, let's continue factoring. So we're going to take out our GCF, which is negative 2x. And then inside of the parentheses, I have an x squared plus 4x plus 3. Go ahead and factor that down. You would need two numbers that multiply to 3, add to 4. I'm not showing my work because this is factoring. So go ahead and factor that down. Can we do a shortcut, or do we need to make a box? Can we do a shortcut? Yeah, because A is 1. So go ahead, find your two numbers that multiply to be 3, add to 4. What would be your two numbers?
3 and 1.
Positive 3 and positive 1. All right, so now let's set each factor equal to 0. Starting with negative 2x, set that equal to 0. Then you're going to take x plus 3, set that equal to 0. And then x plus 1, set that equal to 0. And that's going to give you your x-intercepts. So for the first one, you're going to divide by negative 2, so that gives you 0, 0. The second one, you're going to subtract 3, so that would be negative 3, 0. And the third one, you're going to subtract 1, so that would be negative 1, 0. Let's go ahead and plot those points on our x-axis. And then I like to go ahead and add my end behavior. So off the 0, I'm going to have an arrow going up. And then here, this side is going to go up. Off the 0, I have an arrow going down. Sorry, because the right side goes down. On the left side, it's going to go up. And then your last step is to find your middle points. So when you find your midpoints, I'm going to type negative 2. And what would be my other midpoint? Negative 0.5. So let me zoom into the x-axis real quick. The middle of these two x-intercepts is negative 2. The middle of these two x-intercepts will be negative 0.5. So we just need to type those into our equation. And I'm going to use this format here because I think this one is the easiest to do personally. So that equals negative 2 times negative 2. And then I have negative 2 plus 3 and negative 2 plus 1. Go ahead, see what you get. And for your second one, negative 2, negative 0.5, negative 0.5 plus 3, negative 0.5 plus 1. All right, go ahead and type both of those in and get your 2. And you're done. Okay.
I know it says odd. Is that the beginning where you get negative 2x?
Yeah. So because this is negative and this is odd. So because this is negative, that's going to make the arrow go down on the right.
Okay. And then since it's odd, it goes
opposite on the left.
Okay.
Yeah.
So it's just the opposite.
It's the opposite, yes, opposite of what the right does. All right, so go ahead, type these in your calculators. And I don't know the answer, so. Uh-oh, is that one broke? Let me see it, see if I can fix it. Sometimes I can make him come back. Oh, yeah, no, this is it.
If the coefficient was even, it would go up.
Yep, if the, not coefficient, if the degree was even, then both sides would go down. Okay, what did you all get for the first one? What you get for -2? What you get? 4? Who got 4?
I'm slow.
You got 4? -4? Who got -4? Okay, so -4. So that means at -2, at -2, we're gonna go down to -4. So that'd be right here. So the graph is gonna kind of do this. All right, and now we need to put in 0.5, -0.5. What you get for -0.5? 1.25? Who got something around 1.25? All right, I'm gonna round that to 1.3. Positive, so that means in between here, it's just gonna go up a little bit past the 1. So it's gonna do this. And that looks about right because all of our degrees were odd. And do you notice that at every single x-intercept it went through? So that would be correct. Any questions? All right, one more, and then we'll be finished with 4.2. Go ahead and copy this one down. Last one.
Last one for today, right?
No, this is the last one for 4.2. So first step is always look for our greatest common factor. What would be our greatest common factor for this one? X what? Squared. Let's take out the x squared. So we would have x squared times x minus 4. So set both of those equal to 0. When you take the square root of 0 to solve the first one, the square root of 0 is 0. And add 4, you get 4, 0. So we only have 2 x-intercepts. Let's go ahead and add those on our x-axis. So now let's talk about in behavior. This is an odd positive. Odd because it's a third degree. Positive because that is a positive 1 that leads it out. So this is odd positive. Positive meaning that the right arrow, so that means off the 4, the arrow is going to go up. And what is it going to do at the 0? Is it going to go up or down? It's going to go down. So now all we need to do is figure out 1 point because there's only 2 zeros. And what's the 1 point that I need to, what's the midpoint between 0 and 4? 2. So let's go ahead and find f of 2. So that would be 2 squared, 2 minus 4. So I'm just using this factor form right here. 2 squared and then 2 minus 4. Go ahead, type that in. All right, who got -8? All right, so that means that, and let's see, does this make sense? That means that the graph is going to come up, hit 0, bounce back down, and then come back down to the -8. So it's going to hit the 0, bounce down, and then go back up. Does that look right, though, according to our factors? Because this had an even degree, it bounced at the 0. It didn't go through at 0. It hit 0, bounced back down. And then it goes through at the 4. So I went through one question like every single one for homework 12. It's 4 graphs, and I did one like each one. So you should be able to do homework 12 now. Yes?
Will you always have a 0 as one of your x values?
If you have a GCF of x, if you could take out at least one x, which you can for homework 12, yeah, 0 is going to be one of your answers. So now we're going to do some a little bit harder. So now that's the end of 4.2. So now we're moving on to 4.6. 4.6. Homework 13. Go ahead, title your notes. This comes from your book. That's a good question. I don't think so. Nope. We're not graphing. That was just 4.2. So now we're not graphing anymore. So now we're going to find the real zero. So this is what we're going to do now. Who remembers long division and synthetic division from Algebra 2? That's what we're about to do. Yeah, long division. Chapter 4 is no joke. See, I got people over there on their phone back there. I mean, I can't wait for these quizzes because I'm not showing no mercy either. Especially when I see people like literally just the whole time over there in the corner. Okay, next Wednesday. Next Wednesday is the quiz. All right, so we got this copy down. Y'all ready? All right, so the first thing we're going to talk about is the remainder theorem. So you don't necessarily need to write this down. But you know when you do division, so for example, if I take 3 and I divide it into 91, 3 will go into 91. So we would do 3 and then 9. And we carry down the 1. So we would have a remainder of 1. Remember that from 3rd grade?
Nope.
If it doesn't divide evenly into it, you have a remainder. So what's one way that we can find the remainder? So I'm going to give you a minute to copy down this example, and then we're going to talk about the first thing, which is the easiest part of this chapter, and that is the remainder theorem. So I'll give you a minute to copy that down, and then we'll work through it together. So we're saying if we have x cubed minus 4x squared minus 5, and I divide it by x minus 3, what will be the remainder? What's left over? The remainder.
You want us to solve it?
No, I was waiting for people to write it down. It's okay. Who remembers long division? I'm just curious. That's what we're doing. That's what I'm doing all day. Like, that's what my other math class is doing too, is long division.
Do like 27 divided by 9, I get it.
Oh, okay. But when you got to do like x minus 3 divided into x cubed,
Yeah,
okay.
that's-
I'm going to remind you. Don't worry. That's coming later.
Have we ever done that on random variables being?
We did that. We did it in Algebra 2.
Ah,
Yeah, it's okay. Because Algebra 2 was what, 2 years ago for y'all? Most of y'all? Some of y'all? Okay. All right, so what you're going to do, so to find the remainder, if I'm trying to divide it by x minus 3. So in other words, what I'm saying is, if I divide x minus 3, and you don't have to write this down necessarily. If I divide it into this, what will be the remainder? So to find the remainder, what you need to do is set the factor equal to 0. So take x minus 3, set that equal to 0, and you get x equals 3. So to find the remainder, you simply need to find f of 3. That's it. So you're going to take that 3 and substitute it here and here.
So we were going to divide.
No, we're not there yet. We're just talking about the remainder. I know, relax. So we're going to take 3 to the power of 3 minus 4 times 3 squared minus 5. Go ahead, type that in your calculator. And whatever you get is your remainder.
Should there be a small number? No, that's good.
Let me get, I worked it out. Let me get my answer key. Okay, so I didn't work it out. I didn't type it in. Okay, what you get when you type it in? I didn't type it in for this one.
I'm stressed.
Who got negative 14? I wrote it, but I didn't type it in. Negative 14. So that's your remainder. So if we were to divide it, we would have a remainder of negative 14. So what if we were to divide it by x plus 2? What number would I have to substitute to find my remainder?
Negative 2.
Negative 2. So go ahead and type that in. Now remember, put parentheses around it in your calculator. And again, I wrote it out, but I didn't type it in. I typed it in for the next one, but not for this one. I don't know why. All right, what you all get? Negative 13? Negative 29? Who got negative 29? I'm depending on y'all because I didn't type it in. Raise your hand if you got negative 29. You didn't get that? You didn't type it in right. Show your calculator to Jonathan so he could tell you what you did wrong. So but the majority of us agree that it's negative 29. I'm going with the majority, so it's negative 29. Any questions?
It's negative 2. I put regular 2.
All right, so now let's do a different polynomial with different factors. Can I see your pencil real quick so I can write this down in my... Thank you. All right, so now we're going to do it again. We got a higher degree. Go ahead and copy it down. And again, you're just finding the remainder. So we're not doing the whole division. Find the remainder. So we got a 4th degree, and we're dividing it by x plus 3. So what are you going to substitute the first time? F of what? To find your remainder, what are you typing in? F of what? Negative 3. Because if x plus 3 equals 0, that means x would equal negative 3. So we got to find f of negative 3. Use your parentheses. parentheses, negative 3 to the fourth, minus negative 3 to the third, plus 2 times negative 3 squared, minus 4 times negative 3, minus 8. That's a long one. So don't rush through it. Type it in exactly like that. So I'm recording the class, so you'll have to go back and watch this again. But you can write it down there.
You got 130?
So you're wrong.
130. 130. That's what I got.
I got 130.
Let's see. I actually did do this one. Oh, dang. I got to move now. Let me move over here. Okay. For this one, I actually did work it out. I got 130. Who got 130? So that would be your remainder.
Y'all didn't get 130?
130. Raise your hand if you got that. All right, next one. What are you going to type in? If you're dividing it by a factor of x plus 1, what are we typing in? Negative 1. If you're not getting these numbers, go ahead, bring up your calculator, and I can see what you're doing wrong when you type it in. I don't know. I keep forgetting to make a report for them to come and spray it. Okay. Negative 3 to the power of 4. Go back to the beginning. Minus negative 3 cubed. I don't know where the 4 came from because that should be plus 2. Plus 2. Negative 3. So yeah, you just didn't type it in right. You gotta type it in like it's like you see it up there. You skipped over a term. All right, go ahead, type in negative 1. Thank you. All right, what you all get this time? Who got 0? Does anybody know, remember what that means, though, when you get 0? If you get a remainder of 0, that means x plus 1 is what?
Perfect.
Begins with a F. Has 6 letters. Should we do hangman? There you go. It's a factor. Anytime you get a remainder of 0, that means that x plus 1 is a factor. So that's one of the factors that's used to make up this polynomial. X plus 3 is not a factor because we did not get a remainder of 0. X plus 3 is not one of the factors of that long polynomial. But if you get 0, that is a factor. All right, so now we're going to move on to Descartes, and then we'll end there for today. I know. Go ahead, copy this down.
We gotta make it.
Yep. We'll just do one. We'll just do one today, and then we'll end there. That's what I'm saying. This not the unit to be on your phone with. Because this is all new stuff. This is not algebra 2. This is pre-calc. So we got to lock in. So we have to figure out, and we have to make a table. So I kind of helped you out with the table. And it looks very, very complicated, but it's really not. It just looks that way. Okay, so we need to figure out the possible, how many times this function could possibly cross the x-axis that would be positive real zeros, negative real zeros, or imaginary. So in order to do that, we're going to count the sign changes. So let's start off. This is positive. So when I went from here to here, do you all see how I changed signs? So that counts as a sign change. From here to here, did I change signs? I went from a -4 to a +3.
Yeah.
Yep. And then I jumped from a +3 to a +2. Did I change? Nope. What about from here to here? Did I change from 2 to -1? And then what about from here to here? Did I change? All right, so how many ones did I come up with? 3. That means that for my positive, I can have 3 or 1 because you can only count backwards by 2. You can only count back by 2. So that means that you can only count backwards by 2. How do you count backwards? 3, 2, 1. The 3. So that means that we can have 3 or 1 positive real roots. So put a 3 or a 1. All right, so now I want you to, I'm going to highlight, let me erase all of this. And I'm only going to highlight my odd, the ones with an odd power. And I'm going to rewrite it, and only the ones that you see highlighted in green, I'm going to change the sign. So that means that f of -x, because now we need to find our negative. So that's going to be a -3x to the 7. And then the even stays the same. And then the -3x cubed. And then that positive 2x squared stays the same. And then a positive x. And a -3. Go ahead and count your sign changes now. Count your sign changes. So I went from a negative to a negative. Did I change signs in the beginning? So that's a 0. Then I went from a negative to a negative again, so that's 0. Then I went from a negative to a positive, so that would be a sign change. Positive to a positive, so that's 0. Positive to a negative. So how many ones did I have? 2. So that means in this column, the only numbers I can put in this column would be 2 or 2 minus 2, which is 0. So the total is always your degree. And what is my degree for this? 7. So that's the only number that can go here. And whatever number I put for imaginary has to be positive.
Wait, that's just the highest number?
Yeah, the definition of degree that we discussed at the beginning of 4.1, it is your highest exponent. It's your highest exponent. My highest exponent is 7, so that's my degree. So this row has to add to 7. But I'm missing something because right now I only have 5. So what's the number I need to put here in order for this to equal 7? 2. Imaginary numbers come with a partner. If you have 1, you really have 2. All right, what has to go here in this
Equal 7.
to equal 7? Yeah. 6. All right, so now we need to go back. Well, what if I have 3 positive and 0? Because I haven't looked at that combination. Okay, what if I have 3 positive and 0 negative? Then what number would have to go here? 4. And what's the only combination I haven't talked about? 1 and 2. Look at y'all learning. And what number would have to go in the third column? Who? 4. And that would be 7. All right, I want you to copy down the next one, and so that tomorrow we're ready to go. We won't go through it. Go ahead and copy down this question, and then tomorrow we'll be ready to go through it.